Hi and welcome to Unit 2, Topic 2, Video 18. In this video we're going to do our last solution. So for this last solution, it's worth remembering again that old formula that we don't have, that sine A minus sine B is equal to 2 times sine A minus B over 2, it's a small bracket, cos A plus B over 2. That's going to be handy for us. So the question is saying, given this is the equation, solve for theta. Now you might better play around with this with some double angle formula expansion and summation formula expansion, but that looks a little bit fiddly. What I'm going to do instead is recognise that if A is 4 theta and B is 3 theta, well then we get sine A, which is sine of... No, I don't need to do that. I could do that. In fact, if I don't remember this formula, I could realise this is 4 theta plus 3 theta, and that this is 4 theta minus 3 theta. That would help me. But I don't need to do that in this case, because I've got sine 7 theta minus sine theta is equal to 2 sine 7 theta minus theta over 2 cos 7 theta plus theta over 2. Of course, sine 7 theta minus sine theta is equal to sine of 3 theta. That's given to us, is equal to 2 times sine of 3 theta cos of 4 theta. And of course, they now cancel out, or we have to recall here that actually sine 3 theta could be a solution. So this is the problem, cancelling out. So I'm going to rub that out and make sure that we don't just willingly cancel out, because if sine of 3 theta was 0, that would also work. So instead what we do is we now say, well, let's let sine 3 theta minus 2 sine 3 theta cos 4 theta equals 0. Factorise out the sine 3 theta. 1 minus 2 cos 4 theta equals 0, and now solve using the null factor theorem. So we get sine 3 theta is equal to 0, leading to 3 theta, and keep in mind, I haven't actually, I've been given a range, 0 to pi. So 3 theta is equal to, now keep in mind, if I've given a range, 0 to theta to pi, then 0 to 3 theta to 3 pi is a range I have to work to there, and for later on I'm going to need 0 4 theta to 4 pi. So it's just worth keeping in mind what my range is going to be. So 3 theta has to be sine inverse of 0, which of course is 0, but it's also pi, and it's also 2 pi, and it's also 3 pi. And then I divide by 3, and I get theta is equal to 0, pi on 3, 2 pi on 3, or pi. There's my first set of solutions that works. I should put like extra lines down there. Or my second set of solutions is 1 minus 2 cos 4 theta. This is where the 4 theta comes in, is equal to 0. Double rearrangement, I get cos 4 theta is equal to a half, which means that 4 theta is equal to cos inverse of a half, which hopefully you recall is pi on 3. That's the first quadrant. In the fourth quadrant, we get 2 pi minus pi on 3, which is 6 pi on 3 minus pi on 3, so we get 5 pi on 3. So that works for cos, but of course we've got to keep on going all the way up to 4 pi. So we're adding 2 pi's on as we go, so we get 7 pi on 3, and then we also get 11 pi on 3, and the next one's 13 pi on 3, but that's outside the 4 pi range. Divide everything by 4, and we get theta is equal to pi on 12, 5 pi on 12, 7 pi on 12, and an 11 pi on 12. And there are our solutions. There are 8 of them in total, although, they all work, 0 and pi. We don't have any double ups, so we're happy. All the best.